Very good morning to Dr. Zamri and Dr. Nazin Shah. My name is Namanida Analakitaraj and matrix ID is 211291020, and today we are here to discuss the lab 3 Locus. So the objective of this experiment is to illustrate the root locus responses using transfer function and also to study the effect of loop gain upon the system's poles. So as you can see, this is the introduction, and as you can see, we can move down to the procedure. Given the following transfer functions, plot the root locus. For each GS, indicate as how many poles, zeros and infinite zeros if exists. The first one is 3.1.1. Number 1 is the numerator, 3s squared plus 5s plus 1, this is the denominator. So if you change this into coding, this is the numerator, this is the denominator, 3, 5, 1. This is the numerator and denominator, denominator. This is for the R locus. So I'm just going to demonstrate the graph once again. So here, this is the answer, negative 1.4343, negative 0.2324. So this is the graph. This is the root locus for the first question. And now let's go on for the second one. The second one is 3.1.2, 5 as the numerator, s cubed plus 3s squared plus 5s plus 1. This is the denominator. So if you convert this into the coding, so this is the root locus for number 3. So the answer for that will be negative 1.3855 plus 1.5639i, negative 1.3855 plus minus 1.5639i, negative 0.2291 plus 0.0000i. So now let's go for the next question. So which will be 3.1.3. this is the one, s squared plus 6s plus 1, gs s cubed plus 3s squared plus 5s plus 1. So if we convert it into the procedure, and the coding will be somewhat like this. So I'm just going to demonstrate the graph once again. So this is the root locus. So the answer will be negative 1.3855 plus 1.5639i, negative 1.3855 minus 1.5639i, negative 0.2291 plus 0.0000i. So now let's go on for the next one. It's 3.21. So for 3.21, this is the one. We have to change the coding here in order to find the k poles and R log find. So at k is equal to 0 when gs is numerator is 1, the denominator is 3s squared plus 5s plus 1. So if we convert it into the coding, it will be looking like this. Numerator 1, denominator 3.51, R locus, numerator, denominator, k poles, R log find, numerator, denominator. So this is the one. So this is the point. Okay, so this is the root locus. So the k is 0.120, the poles is negative 1.309, negative 0.2357. So this is the procedure, 3.22, and I'll be showing you the demonstration. So here, this is the root locus, and here, so this is the one. this is for procedure 3.23, and for the selected point is negative 0.8344 plus 0.0012 I, K is 0.833, pose is negative 0.8333 plus 0.0007 I, and negative 0.8333 minus 0.0007 I. So for the next one, 3.23, the question will be this one, 3 as the numerator, denominator is 3s cubed plus 4s squared plus 2s plus 1. So if we convert it into the coding, it will be somewhat looking like this. So this is the root locus, and let's just in it. So this is the one. So the points will be negative 0.0012 plus 0.7966I, and for K is 0.5118. As for the poles is negative 1.3151 plus 0.0000I minus 0.091 plus 0.8016I, negative 0.0091 minus 0.8016I. So for the last one, the 3.2.4, 6 is the numerator, the cube is s3, s cube plus 2s squared plus 8s plus 3. This is for the last question. So let us see, this is the numerator, denominator are locus plus k poles. So this is the 1, if you really see this is the 6, and denominator is 1283, and as you can see so this is the points, 0.0118 plus 2.7950I, K is 2.1373, the poles is negative 0.0074 plus 28232I, negative 0.0074, negative 2.8232I, negative 19853 plus 0.00I. So as for discussion, let me make it smaller, minimize it. As for discussion, question 3.11 has a total of 2 poles and 0 zeros. Therefore, there is no relationship between the zeros and poles. Consequently, the 2 poles have now receded to an infinite distance when the 2 poles move towards infinity and there are more 2 infinite zeros. Question 3.1.2 is analogous to question 3.1.1, where there are 3 poles and 0 zeros. Due to the absence of zeros, the poles have shifted towards infinity. When there are 3 poles heading towards infinity, there are 3 zeros that are infinitely large. Question 3.1.3 has a total of 3 poles and 2 zeros. Assuming that there should be 2 infinite zeros due to the presence of 2 pairs of zeros and poles, it is important to note that there is only one pair of zero and pole that overlap each other, which cannot be considered as an infinite zero. Thus, there is only one infinite zero. In question 3.2.1, the value of k has been adjusted iteratively until it reaches 0, as shown in the output graph. When we fail to obtain the desired value of 0, we must continue doing the run and select operations until we approach the closest value to 0. I have successfully obtained the value of k as 0.0071 for this inquiry. Next issue is 3.2.2 poles intersect at the origin 0 and 0, y and x and y on the graph. When the specific point is chosen, the obtained value of k is 1.0833. Question 3.2.3 involves a scenario where poles separates complex plane where the poles began to diverge, intersected at y-axis determined based on the output graph. The value of k found is 0.5118. Lastly, for question 3.2.4, The given scenario involves poles detaching and entering the correct lane. In light of the above circumstances, the closest poles that have been selected are the ones adjacent to the right pole. Hence, the obtained value for K is 2.1373. And to conclude, this lab has examined the utilization of MATLAB for software analysis as stated in question 3.1 and 3.2. Subsequently, the techniques for depicting root locus actions using transfer functions have been acquired. In addition, the methods for examining the impact of loop gain on the poles of the system in laboratory setting have been examined. The infinite zeros for the problem in 3.1 have been determined, and the gain and poles for these corresponding conditions have been found for the questions in 3.2. Hence, all the goals of this experiment have been successfully accomplished. And I've already attached the rubric. So I guess that's it, and thank you for listening and have a nice day.